think we're live. Hello, everyone. Welcome to our Code Yourself Hangout. My name is Arati Manataki. I'm one of the course organizers.
And I'm Ben Clavier, one of the new TAs.
And we're excited, we're delighted to be here and having this session with you. So what is a Hangout about and how does it work? Basically, it's an opportunity for us to touch base and show you we're around, and we've been looking what has been going on with the course, and also talk about things related to coding. Any questions that you may have, or news in this area, that's what we're here to discuss today. We're planning to keep things fairly short, so not longer than half an hour, we hope. You're more than welcome to post your questions in the chat. We'll try to keep an eye on it. And yeah, maybe we can get started then. So we can start perhaps by reminding you what the course is about and what things we cover in the course. So it's a free online course available on Coursera. It's called Code Yourself, an Introduction to Programming. And it's a very gentle introduction to computer science, to computational thinking and software engineering. And the language that we use for programming is Scratch, which is fully visual, block-based programming, so you don't need to worry about syntax. And we learn how to build animations and games. And we've seen a lot of those in the course. So just to remind you the kind of topics that we cover, we look at, in terms of computational thinking, we look at sequence, selection, iteration, abstraction, decomposition, so how to break things down, which is always a good idea when doing programming. We look at some very basic ideas in software engineering as well. So the fact that it is important to test your code, the fact that it is important to sit down and think about what it is that you want to do before you actually go and implement it. And in fact, in week one, we have an interview with a researcher that used to work here in the School of Informatics in Edinburgh, who tells you exactly this. Take a sheet of paper, a piece of paper, pen or pencil, and just scribble your ideas there. And then we learn a lot about Scratch, which is a lot of fun. What sprites are, what things you can do with them, the fact that you can create your own block. In week 5, we look at cloning, which means replicating behavior for different versions of the same character, the same sprite. And yeah, and we see a lot of cool programs that you share in the forums as well. So that's pretty nice. So the course has been running for a few years now, nice and steady. And over the years, we've had thousands of learners. And by thousands, I mean, so I checked just before this session, right? And it's about 143,000 learners in the world. And I think this is quite amazing. So we have people from Chile, from the States, from Pakistan, Kenya, Japan, Greece, all sorts of places. And what I thought was interesting, that perhaps worth mentioning, is that about 42% of our learners are female, which is actually quite good for a computer science or programming related course. And it's also slightly higher than your average course on Coursera. So yay. Also worth reminding our learners that there's a Spanish-speaking version of the course called A Programar. I don't know if you've checked it out at all.
Not really. Yeah. Well, I've tried, but I don't really speak the language. I don't like it.
Yeah. So you've probably seen Ines, who is the teacher in Spanish, in some of our videos. So we share some of the content, and all the videos are more or less the same. The Spanish-speaking course, well, both courses really were developed in collaboration between the University of Edinburgh and Ort Universidad Uruguay, a university in Uruguay. And A Programar has been going really well. So if we have any Spanish-speaking learners, just bear in mind that there's a Spanish-speaking version as well, which is excellent. So you might find that useful. So Ben, who's here with me today, is the new teaching assistant in the course. And one of the main things that you do, Ben, is looking after the discussion forums. Is that right?
Yeah, I make sure that there's nothing in the forum that is clearly a problem to too many people and that stops you from actually being able to complete the course. I think the main issue that has come up quite a lot is that the course is run on Scratch 2, which is the previous version of Scratch. But now at the MIT website, in the online version, use Scratch 3, which is a better, improved version of Scratch 2. The underlying blocks remain the same, but they've changed the interface and they've added new features. And because of all the changes they've made, the two versions are not compatible with each other. So there's been two main issues with this, so that you'll be watching the videos and generally you'll be told to just use the Scratch MIT website, which will take you to Scratch 3. And the interface won't be quite what you'll be getting in the videos. The way to do a lot of things will be slightly different in a way that's really easy to get thrown off. And the second issue is that you're supposed to upload your project for the assignments at the end of week 3 and week 5. And people are quite scared if, like, is Scratch 3 okay? Do I need to use Scratch 2? Why can't I load mine on the online interface? So I've made a post on the forum which is pinned and which a lot of people have viewed and it seems to be going smoothly, but I just want to make it really clear. Both versions are okay. If you can still download Scratch 2, if you feel more comfortable having the same interface IT in the videos, it's still available to download on the same page. You can just click download Scratch and then pick version 2 instead of 3. If you started using the version 3 instead of version 2, that's also perfectly fine. You can upload Scratch 3 projects, which are .sv3 instead of .sv2. And we will mark this, and these will be reviewed by other students, and they're fine. They will load just fine. There's no need to panic because you're into week 2 and the assignment starting soon, and you're like, oh no, I've been using the wrong version. You can keep using what you've been using. Just do whatever works for you. Scratch is still mostly the same, and the goal is really that you learn the basics of programming. So what's important here that is not the version of Scratch you use, but the concepts, and the concepts are the same between the two.
Absolutely. Yeah. And the things we ask you to do in your programming assignments, they apply to both Scratch 2 and Scratch 3. Isn't that right?
Yeah, they would even apply to other programming languages.
Yes,
it's really,
absolutely.
The assignments are about your understanding of stuff like the data structures or how to interact. It's not really about mastering Scratch itself, so you don't need to really worry that you're using the wrong version and won't get anything out of it.
So just to emphasize the fact that there's a discussion pinned in the forums.
Yeah.
So if you're not sure, just go to the discussion forums and you'll be able to find it at the very top.
Yeah, and if you really are unsure, just answer the pinned thread and I'll be there and I'll explain to you what's wrong and what you should do. If you're really scared of doing something wrong, that's fine too. We're here to help you, so don't hesitate to use the forum. Absolutely.
I mean, the whole idea of this course is to provide a gentle introduction to programming. And when you're really new to this, it can seem very scary and you probably have many questions, and that's absolutely fine. For me as a teacher, it's strange when there are no questions because when there are no questions, you think, probably they haven't really thought about things or they haven't really tried them out. So please do ask us questions and ask your classmates too. So anything else that you might want to tell us about the forums?
Yeah, I see a lot of people post their algorithm. I think that's really nice because we can comment on each other's algorithms and suggest improvements. I think something that's quite important is to take into account what assumptions we make, because it's really easy to see things that are really normal for us. It's like, one recent example is if I want to draw a square, I'll draw a line and then I'll draw another line. And if I start vertical, I'll go horizontal next or the other way around. And that makes sense to you. And when you're asked to draw a square, you will always do it like this because that makes sense. But if you tell the computer to draw, say, an horizontal line, then a vertical line, it could draw the vertical line in the other direction, and you ask it to draw another, and then it draws it in the wrong direction, and it just looks like this. It's no longer a square. So I think what's important and what's really useful, and that's why you should practice algorithms, because it's not intuitive. We are used to common sense because we have common sense. Computers really don't have common sense. Computers, they know what you've told them to know, and in programming languages like Scratch and stuff, they've been told the things, so they know that if you ask the sprite to move slightly to the right, it will. But if you ask it to just draw a line, it doesn't know what a square is. It's not going to try to draw a square. It's going to draw a line. If you don't specify that the line needs to go to the right, it might draw it to the left or to the top or whatever. So what's really important is that practice your algorithm skills and keep posting on them on the forum, because it helps you realize that everything you assume, you can't assume it with a computer. And that's really the main problem with programming. That's what, done to your career 10 years and you'll still be struggling because you assumed something was simple and it's actually not.
Yeah, that's a very good point. And what I found very useful from these discussions at forums is when your classmates come in or when you read the algorithms of students.
Yeah.
So it's interesting that you mentioned this idea of the assumptions that we make. I think this is a key concept in computer science. There was one post in the post which I really enjoyed, which take this to almost the extreme, but in a good way. So let me see. Remember in week 1, we asked you to provide an algorithm to teach an alien how to brush their teeth. So we have an example of such an algorithm. It's provided by a learner. Now I might not be pronouncing your name very well. It's Jun Kai Wen, who provided an algorithm for this. So basically instructions for an alien. And they start by saying, well, first you need to find where your mouth is. And then you need to find where your teeth are. And then you need to find something that is a toothbrush. So I think it's a very, very good point. Because, well, maybe the concept of a mouth is not that clear to an alien. So we always need to go back a few steps and think, okay, what can we assume that we know here and what not? And you try these things out and see what works and what doesn't. But yeah, good post, good discussion. That's all very good. Is there anything else? Any other questions that come up in the forums every now and then? Anything you want to comment on?
Well, a question that occasionally comes up is at the end of week 5, where to go next, like what to do after Scratch. And the generic answer tends to be do Python because it's considered as one of the simpler programming language. And on top of that, it's like quite reminiscent on Scratch in the way it handles some of the logic. But something is that Python is a big language and it's quite hard actually to find the course that fits the best after code yourself. So,
yes.
And I struggle to give you like the best answer to that. So I think we're going to talk about this like a bit further, maybe in another video or something.
Yes, so we thought it would be a really good idea to have another Hangout specifically for this, so dedicated to what next. And we can suggest a few courses, a few textbooks, a few websites where you can have a look at and see whether they work for you. Off the top of my head, I would probably say do have a look at the Code Academy website. It's an online learning platform and they do include resources on Python. You can try them out for free. So I think it's a good place to start. But also do have a think about what it is that you want to get out of it. I think that will help you choose the right next step. Yeah, very good. So shall we move on to some news then around the course? So in addition to this online course, we run a few face-to-face sessions with different kinds of learners. Most of these workshops and events, they take place in Edinburgh, but others further outside of Edinburgh. So just a couple of weeks ago, we ran a workshop called Demystifying Coding Demystified. And it was part of the Audacious Women Festival, which is a fairly new festival in Edinburgh, if I'm not mistaken. So it's about inviting female adults to try something they never thought they dared, which I think is a really great idea. And we had about 30 women trying out programming. We used Scratch and we used some of the materials in the course. And I have to say, I was so impressed with the projects that they came up with. Some of them went for chasing games, so a ghost chasing a human. Others went for a story taking place in space, so an animation. Others had football games, which can actually be quite complex to program, especially if you want like a smooth flowing football. So yeah, but well done. And it just goes to show that if you spend a couple of hours, 3 hours in a group of people with some support, the things that you can achieve, I think it's amazing. So what I thought I'd highlight is the fact that the course materials, you can reuse them for your teaching if you're a teacher, or if you're excited about programming, you want to share the knowledge with others, you can run a session and just basically pick a few videos, a few examples of Scratch programs and work around those. So the course license allows you to do that. And in a way, this is why we built the course, to share our passion about programming, and hopefully these resources will be used elsewhere as well. So, and in fact, if you have any ideas or if you want to share any stories around how you've used the course resources, please do let us know. We'd be delighted to hear about your stories. And talk about stories. So a few days ago, I received a very heartwarming message from a previous learner. So her name is Tamari Lukava. She took this course, Code Yourself, a few years ago, maybe about 3 years ago, I think. And it was her first introduction to programming. She really enjoyed it, and she went on to learn more around coding. And she mentioned that from September onwards, she'll be doing an MSc in computer science. So this is really amazing.
Amazing.
We don't expect everyone to go and do an MSc in computer science afterwards, and you don't really have to. This is not the point of the course. But it's really great to hear that sometimes people can be inspired and empowered to go for this direction. Yeah. Excellent. Well done, Tamari. And finally, I thought I'd let folk know, people that live in Edinburgh or in Scotland, about a workshop, a coding workshop that we're running for kids. So it's called Game On. It's part of the Edinburgh International Science Festival. It's a lot of fun. We basically use some of the ideas that we have in this course. But we offer a session, a 1 hour session, where really you just go there, work with a partner, and build a game. Yeah. So it's really a lot of fun. And in any case, if you're not available those days, so 4th to the 8th of April, where Game On is taking place, do have a look at the Edinburgh International Science Festival. Their program is amazing.
It's really cool, and you can really find out about like every area of science from people who are like world-leading researchers and will be willing to talk about it at a very low level, so everyone can understand it. And it's really a great opportunity if you're anywhere near Edinburgh. It's really amazing. There are events for any kind of age, any background, and different formats of events. So you can have workshops like Game On, you could have talks, you can have debates. It's really a lot of fun. Highly recommended. And I think that's everything I wanted to share around Code Yourself news. Now, Ben is fairly new to the course. So we've had different teaching assistants in the past who have made this course a success. We're really delighted to have Ben join us. And given that this is our first Hangout, we thought that it would be really good to just have Ben introduce himself and tell you a little bit about his journey in programming. Okay, so I'm Ben. I'm from France, and I did my undergrad here in Edinburgh. And then I went back to France where I worked in industry for a couple of years. Then I came back to Edinburgh in September to start a PhD in AI for education. So IT is actually my co-supervisor on my PhD. So what I'm doing here is essentially I used all the techniques that you might have heard of, or maybe not, but they're often in the news these days, which are like machine learning or AI, which is to essentially use very complicated algorithms to try to learn from data. And data can be anything. When you speak, that's data. When you write down something, that's data. When you click on something, that's data. So we really mean data in the broad sense. And my PhD topic is focused on learning analytics, which is learning, like using the data that people generate when they try to learn, when they interact with maybe Code Yourself, for instance, and trying to make education better, because every year there's more people accessing education than ever before, thanks to technology and stuff. You can, like courses like Code Yourself before, you would never been able to access this. Now nearly 150,000 people have been introduced to programming with one course. And the problem is that there still aren't like millions of instructors, so we need better tools so that we can better support learners, so that we can be there to help you as efficiently as we can. And that's the field of AI for education, of learning analytics, is finding good ways to develop these tools and to try to understand how people learn, like what makes people more likely to remember something, or even what makes people more likely to enjoy a course and then want to learn more about it. And broadly, my PhD topic is about this currently.
Very good. Now, you mentioned AI, and there's a lot of buzz and hype in the media around AI. I think one of the fears that are very often discussed or concerns are around automation and machines taking our jobs, basically. So what are your thoughts around this when it comes to AI in education? Do you think machines, so maybe in 50 years there's going to be no human teacher and only machines?
No, I don't think so. I think like there's something that we call the human in the loop, which is when you have a lot of AI, but it's ultimately just used to give more information, to give more power to the human element. And I think in like socially relevant topics like education or healthcare, or from interacting with you, I think what's important to bear in mind with AI for education is that we need to teach more people, and we need to teach them as well as we can. So AI is there to help us, but I don't think AI is there to replace anything. AI is there to give the instructor much better tools so that you can learn much better.
So as someone that works in health informatics and AI in health, I can say that this very much resonates with me. So this is what we would expect, or what we would hope in AI-enabled healthcare. Still keep humans in the loop and keep humans driving healthcare services, but have some help when you can and when it makes sense. And I'm wondering, Ben, you said you did your undergraduate here and then came back to do your PhD. So how does one come to do a PhD in informatics? So was your undergraduate in computer science, or was it something related?
Yeah, my background is in computer science. I've also studied social sciences, but it was more of a minor, so to say. So my focus was always computer science, and I was always quite interested in AI and machine learning because honestly, at the time where I picked to study, it was really cool to be like, oh, the robots. And so I have a better understanding now, so it's a bit less hype-ish, but it's still really interesting.
Very good.
Before starting to do a PhD, I just thought I wanted to go to industry and try to explore what was out there. And I decided to come back to do a PhD because I really wanted to work on maybe more socially impactful topics like education work or healthcare work, which is harder to combine in industry, obviously.
Yeah. And what do you think attracted you to study computer science in the first place? So were you one of those kids that always used to code, or were you someone that came to university and then learned how to code and think computationally?
I learned programming a bit when I was like 14 or 15, but I was never very good at coding. I wasn't one of those kids that at 12 can code amazing things or anything. I think what ended up attracting me to computer science is that I just like solving problems, and it's essentially just about solving problems and just continuously solving new issues and finding new ways to do things. I think that's what's really interesting. I also enjoy like fast-paced environments. So like the field of machine learning, for instance, you have a revolution every 2 years, and I think that's really interesting to just have a constant feedback loop of new science coming through.
Very good, yeah. And so it's been a journey for you. I wonder if you can think back to your very first steps and perhaps reflect on how much you've evolved over the years. What would you advise people that are just very new to this, to learning about computer science, learning about programming? Do you have any tips that perhaps could help them?
Yeah, I'll say don't get discouraged, and that sounds very cliche to just say keep at it. But people share their success. When you look at GitHub or anything and you see those people with like 10 amazing projects, because they've put their 10 amazing projects there. But at the start, they were just like you. They were trying to fix a really simple issue and taking 3 hours. And then you look back on it 2 days later when you've worked more, or like 2 years later when you now have experience and you solve the same problem in 5 minutes and wonder how it ever took you this long. And now you are accomplished and you've got your own projects out and people see your projects. But nobody really knows that at the start you struggled for 5 hours on really simple issues. And everybody did. Nobody had gone into software engineering or anything was ever, well, maybe a few people were, but most people struggle. Most people took hours on like maybe fixing a comma in the wrong
Yes.
place or things like that.
Absolutely.
We still do.
We still do.
So it's important that it's kind of like social media. What you see are the highlights,
Yeah.
and you need to remember that before the highlights, you struggle a lot. And well, it's always satisfying when you manage to fix your issue. So just keep working at it, and eventually things will be clearer, and it will take you days to do what took you weeks.
Very good, thank you. And we were chatting earlier along those lines, so about giving it a go with something a bit more challenging, like an assignment, and what you've learned from the learning analytics work that you've done.
Yeah.
So would you like to tell our learners?
Yeah, we've actually taken quite a deep look at the code yourself data, and we found that the time where most learners give up is in week 3, right before the assignment. And that even the people that do give up in week 3, most of you end up watching the lectures, but when you get to the assignment, people don't submit it, and sometimes they just leave the course altogether or wait weeks before coming back to it. And obviously, it's very clear why. It's daunting because that's the first time you have to actually do a piece of work that you need to be proud enough of to submit. And I think don't be scared of that. It's formative feedback. It's not like you're going to fail anything, or it's just to let you know how well you're doing, to see what you're grasping. And computer science is complicated when you just talk about it, when you read about it. It's much clearer. Some concepts, maybe you will never understand them until you try to program them, and you're just, oh, that was that easy. Yes. And then and so I think you shouldn't be scared of the assignment. It's not meant to trick you or anything. There's no trap.
No.
It's really just a friendly test to help you to practice what you've been learning about.
Absolutely, absolutely. And this is really an opportunity for you to test what you've learned and see what gaps there might be, so you can go back to the corresponding part of the course. And perhaps we should also tell our learners that you can resubmit if you want to and get your assignment marked.
Yeah, nothing's final.
Yes.
Even if you do badly because you misunderstood something completely, that's part of learning. Like just failing is a part of just the natural learning process. So you could fail and then resubmit it 2 or 3 times until you finally understand what was blocking you, and then you get an amazing submission. So don't be scared. Like it's not, oh, I failed the assignment, that's my course finished. It's not the case.
Yes, absolutely. So if there's one thing that I've learned since starting working in computer science and informatics is, well, failure is part of what we do. Both people doing some programming, because not everything's going to be working all the time, but also in research. So, you have some ideas and you think, oh, this is brilliant, it's going to work, and then it doesn't. And you can view this as a very negative thing, as a failure, oh, I did this wrong. But you can also view it as, okay, we gave it a shot, now we know what works and what doesn't. So, it's just moving on.
It's actually a bigger and bigger thing in science, where researchers are wanting to encourage people to publish negative results, because something was still learned, like having the end result be negative don't mean that the experience was negative. Maybe you got the assignment wrong, but maybe getting that wrong helps you understand 3 out of 4 things, and then you can do better the next time.
Absolutely, yes, yeah. Great, thank you. Is there anything else that you would like to tell our learners before we say goodbye?
I don't think so.
Okay,
I think we covered everything, yeah.
Okay. Your wishes, your fears, your projects, and do rate us. We do have a look at the stories that you share and the ratings that you give us, and we very, very much value your feedback. So do let us know what you think about the course.
Yeah, and do check out the forums if you're not currently on them, because it's really useful to talk about what you're learning. It makes you feel a lot less alone when you see that dozens of people are struggling with the same things.
And it's a lot of fun to speak with other people, the other side of the world. Great, thank you very much. We'll try to keep these sessions regular, so every month or every second month. In the meantime, we're looking forward to your discussions in the forums. Thank you.
Thank you.
Bye.